Our topic tonight, as I said, it's nutrients. It's kind of the second, well, we need to know the science and background of nutrition before we can talk about how to actually feed them, how to talk about the problems. And so one of the things we always forget, and I think this is true with human nutrition too, is we don't need specific foods. We need certain nutrients. And we can meet those nutritional needs by eating a variety of feedstuffs, or food in the case of people. And it's the combinations that are more important than the individual food. Bernadette, did the audio improve by shutting off the video? Great, great. I'm glad the audio improved. Whether we're talking people or animals, we all require 6 essential nutrients. And we're going to go through each of these. Again, this is what animals and livestock need, nutrients, not specific feeds. Water, protein, energy, fat, vitamins, and minerals. We're going to go through each of these. And then as we go through, after we go through each of these, we're going to look at how they change according to whether we're feeding a sheep or a goat, how old the animal is, what sex the animal is, where it is in its production cycle, what's its level of production, all the things that then affect those requirements. So most of our feeds, all of our feeds contain at least one of the essential 6 nutrients. Most of them contain all of them, but they vary in how much they have of each nutrient. And there's no single feed or food that can meet our nutritional requirements to allow us to survive and thrive. Whenever somebody tells me a food is good for them, I say, no, it's not, because if that's all I ate, I wouldn't be very healthy. I'd probably die. It's the combinations of food that are important, not the specific foods. Of course, the nutrients that the individual combinations have is very important. The other thing is, and we've already brought it up a little bit in the chat box, is that there are linkages or relationships between essential nutrients. Copper, molybdenum, and sulfur. Selenium, vitamin E. Lots of interactions. Protein, energy. If you underfeed energy, the protein requirements are higher. So there's lots of different interactions. And our job, or our goal, is to balance these different feed ingredients, these combination of foods, to meet the animal's needs. Again, it's the same in human nutrition. You know, it's why our typical meal has always been kind of like a meat or a protein, a starch, and vegetables. That's trying to balance all the nutrients by using different types of foods. We do the same thing with livestock. And of course, the nutrients that the animal needs varies according to many factors. Again, I already mentioned them: species, age, stage and level of production, the weather, the climate. If it's a lot colder, you know, they need more nutrition just to keep themselves warm. The most important nutrient, and one we often don't even consider a nutrient, is water. Bodies are predominantly water. Water has many, many, many functions in the animal's body. And how much the animal needs, again, varies by the same things I just mentioned: the species, the stage and level of production, the climate. You know, they're going to drink more water in the summer when it's hot, less in the winter when it's cold, particularly if the winter water is cold and icy and the summer water is hot. You know, they're going to drink more. The more they drink, the more they eat. The more they eat, the more they drink. Milk is mostly water. Obviously, lactation places the highest requirements. Sometimes through the year, it seems as if the animals drink no water at all. And that's because they can get moisture out of the feed. And it's always important to remember that as a nutrient and as a requirement, it's both quality and quantity that we have to be concerned about. They need so much water, but the quality of that water, again, whether it's temperature or other things in the water, that can affect how much they consume. After each nutrient, I want to show you a table in terms of common feeds or unique feeds and the percent they have of each nutrient. In this case, I'm showing you not how much water, but how much dry matter. So in the case of lettuce, it's 5% dry matter. That means it's 95% water. Feeds provide some of the dietary requirement of water. That goes without saying. Obviously, if you fed your sheep lettuce, and I do know a producer who has done that, they're ghostly getting water out of that. But where the moisture content of the feed is especially important is when we're balancing a ration. We balance rations on a dry matter basis. And so if a feed has a lot of water in it, they need to consume a lot more of that particular feed, and very often there's a limit on how much they can consume. A perfect example is corn silage. It's 34% dry matter, what's that, 66% water. It's excellent quality feed, if you very high energy, but a high producing animal, a lactating goat, a growing lamb, they actually can't eat enough of it. Same thing's true with pasture. Pasture has a lot of water in it, and it's not that it's not high quality, especially in the spring, but they literally can't eat enough to meet their requirements. Most of the supplements that we give, the grains and the hays, they're pretty high in dry matter, just a little short of 90%. Same thing with silage, alfalfa silage, yes, lots of moisture. That lamb on the right is actually eating pineapple. And you can imagine that that's a high amount of water in that feed. Very succulent feed, very nutritious, but a lot of water. Carbohydrates and energy are definitely the most important part about the ration, in the sense that this is the nutrient they need in the highest or the greatest quantity, calories. It's the building block for other nutrients. If we feed too much energy, of course the same thing's true with us, we store it as fat. We get fat, they get fat. There's a lot of different ways that energy is expressed as when we start talking about reading feed tags or balancing rations. Total digestible nutrients, TDN, we're going to use that a lot, that term. That's the crudest measure of energy. It's the one we tend to balance sheep and goat rations with. If we were balancing chicken or pig or even cattle rations, or dairy cattle rations, we'd use the more sophisticated ones, metabolizable energy, and then the last one, which is net energy. It's just kind of a degree of sophistication. But feeding sheep and goats, I guess I would say, is less scientific. The productivity is not as high as it would be for a lactating dairy cow, so we tend to use TDN. Feeds vary tremendously based on the type of feed we have. If we feed fat, and this could be the plant source of fat or an animal source of fat, from a percentage standpoint, it's 195%. It's hard to comprehend that. Just you need to understand it's just that much higher than these other feeds. Our highest sources of energy are going to be usually our cereal grains in the 80s. Corn being the standard, up around 88%, barley 84%, oats would be down probably about 76%. Our forages are moderate sources of energy, be they silage, pasture, or hay. When they're cut, or graze, can also affect that percent of energy quite a bit. I was going to say, I saw the question about corn cobs. Corn cobs are going to be lower in energy than most all the feeds up there. They'd probably be somewhere around oat straw. You know, you think of straw as simply a bedding, but it is a feed, and when the animal doesn't have real high requirements, it does provide nutrition, and as David mentioned in the chat box, it provides filler as well. But you just got to know the content of what you're giving as you, again, put the combinations together. We don't think of ever balancing a ration for fat, but it is a requirement. It's a source of heat insulation and body protection. We have essential fatty acids that we require in the diet. It's also the cheapest source of energy and has 2.25 times as much energy as carbohydrates. Ruminant diets tend to be below 4% in fat. Monogastric diets tend to have more fat. What's interesting about fat nowadays is we can change or manipulate the fat in the animal's diet to affect the profile of the meat. You know how you hear that grass-fed meat has a better fatty acid profile than grain-fed meat? That's actually not true, because we can manipulate that, quote, feedlot diet to produce the same thing. It just has to do with whatever we want to feed it. If it's just a traditional corn soybean diet, that's certainly true. But if I started feeding linseed oil or fats that are going to change the fatty acid composition of the meat, I could accomplish the same thing I do on grass. Now, it's not as simple as that. There's lots of things that go into that decision of how to fatten animals or how to grow them out. So if we look at the different fat contents of some of the feeds, again, obviously pure fat, vegetable or animal fat is going to be the highest. And sometimes with high-producing animals, fat is added to the diet. Typically it's added to the diet to reduce the dustiness of feed, make feed taste better. But as you can see, most of our typical feeds are below 5% in fat. Few of our co-products are much higher in fat, like whole soybeans, much higher in fat than, say, straight soybean meal, because they still have the fat in them. And we can feed that to sheep and goats with a functioning rumen. I often tell people that one of the ideal rations would be corn and whole soybeans, because you could mix it to have a very high protein ration and a very high energy ration, and the soybeans would be very high. Of course, that would be missing sources of minerals. But if you're just looking at energy and protein, that would be a pretty ideal ration. And as I mentioned, ruminant diets are typically fairly low in fat. No, soybeans do not need to be roasted to feed to sheep and goats. Certainly they do for monogastrics, and it's often they're done for cattle. But just like sheep and goats can handle whole grains very well, you typically benefit from processing them for cattle. Protein, of course, is the most expensive ingredient in the ration. And if we feed too much, which we often have a habit of doing, that protein is simply converted to energy or fat. In our monogastric animals, overfeeding, or any animal, overfeeding protein also puts more nitrogen into the environment. There's a lot of reasons why you shouldn't overfeed protein. As the animal gets older, protein need reduces. Of course, ruminants don't require as high a quality protein. And we talked about some of the terminology last week. Typically, we look at crude protein as what we'll balance the ration for. The new requirements, sheep and goat nutritional requirements, they list crude protein out by the amount of bypass protein, which is that UIP, undegradable intake protein. That's the protein that gets past the rumen and gets into the abomasum. The DIP, degradable intake protein, that's the protein that is broken down into the rumen. But you'll actually see the crude protein requirements in the new nutrient requirements. And I say new, but they're 5 years old. But you'll see it broken down to percent bypass protein. And then metabolizable protein, that's rarely used in balancing rations, but that would include that protein, again, the bypass protein along with the protein made by the microbes that also gets down to the abomasum. But we simply tend to look at crude protein. Again, the feeds vary tremendously in terms of the amount of protein that they have. Urea, which is basically non-protein nitrogen that the rumen microbes can convert to protein, is 288% protein when we're balancing a ration. We can give it to animals with a functioning rumen. We can make it a certain part of the ration. We can't overfeed it. But that's our highest. Something like straw, corn cobs, things like that would be really low. Our grains tend to be, and grass hays tend to be relatively low. Fresh growing pasture can be pretty high. Obviously alfalfa hay, this is just mid-bloom. You could get higher if you harvested it earlier. Pretty good source of protein. Of course, a lot of people feed the tubs, the poured nutritional tubs. They can be high in protein. Some of our byproducts or co-products like distillers, grains, corn gluten meal, they're high in protein. And then, of course, our primary protein sources. Soybean meal is our primary source. There can be a 44 or 49%. Fish meal is the animal sources are the highest, but we can't feed meat and bone meal from ruminants to ruminants. Fish meal would be the primary one. We talked about that one last time. Fish meal has a very high, much higher level of bypass protein, so including it in rations can provide a performance boost. Where you would be careful is not to feed it to a lactating female that you're using the milk, because it can produce an off flavor. So we've got all different sources of protein and different levels. Okay, the minerals. Basically, there's two types of minerals that they require, and it has to do with not always their importance, but how much they need. And the macro minerals, the requirements are in grams. They still aren't big numbers, but they're significantly higher than the micro minerals, which requirements are in milligrams. Because if you'll notice, selenium, I hope most of you understand the chemical, the letter designations for these chemical or elements. But selenium is needed in milligram amounts, but is obviously very important. Copper, again, milligram amounts, but it's obviously very important. So it's the amount they need, not necessarily their importance. All of these minerals have, many varying functions. We tend to balance rations for calcium and phosphorus because, again, they're needed in large amounts. NaCl. Na and Cl, of course, would be sodium, and chloride, which would be salt. But they're all important, some more important than others, but it's based on how much the animal needs in terms of the amount. Looking at calcium and phosphorus, again, the ones we balance rations on, I basically ranked these feeds according to how much calcium they have, going from the least to the most. And corn has a very low amount of calcium, as do all of our grains. Our hays are better, our byproducts are better, and the feeds at the bottom are what we use to supplement calcium when the ration is deficient in calcium. The next column shows phosphorus. And again, while our grains and typical grain are very low in calcium, they're high in phosphorus. And what happens with that? If you fed this ration to male goats and male sheep, especially castrated ones, again, you fed that, let's say, remember I said the whole soybeans and corn, from a protein energy standpoint, that'd be like an ideal diet, but it would be very low in calcium and very high in phosphorus. And if they weren't consuming a lot of hay or forage to get some more calcium, you would be asking for urinary calculi. You would be asking for it. And so I've just kind of highlighted those. The percentage of calcium and phosphorus you often hear should be 2 to 1 in a ration for male goats and male sheep. In terms of females, productive females, that ratio is not really significant because they have actual requirements for calcium and phosphorus that don't always result. A lot of times they need a lot more phosphorus. So, but if you're balancing a ration for males, 4-H lambs, wethers, whatever, it's essential that that entire ration have a balance of about 2 to 1. And so again, the straight grains would not provide that. If they're strictly on pasture, like say animals were out on fescue pasture, 1.3, so that's 1.3 to 1. You're not likely to have any problems. And of course, there's other things about urinary calculi to help prevent that besides just the ration. The ration is just the primary one. In our last session, we're going to talk about stuff that can go wrong from a nutritional standpoint. We'll talk about urinary calculi. We'll talk about pregnancy toxemia. We'll talk about milk fever. We'll talk about some of the things that can go wrong. Vitamins, there's basically two kinds of vitamins, water-soluble and fat-soluble. Again, they have multiple functions in the body. Generally, the requirements increase with age. And if you remember from last time, we don't actually need to give them vitamin K or B complex. The microbes in the rumen can manufacture those vitamins. On the other hand, when we have an animal off feed, very often we'll supplement them with B complex vitamins in hopes of stimulating the rumen. Alfalfa does have a... Oh, I got to let David answer the questions. Never mind. Just what are some of the vitamin sources? Well, vitamin A is manufactured from beta-carotene, and the best source of that is our green pasture forage, hay, dehydrated hay like pellets and cured hay, and obviously vitamin supplements. Vitamin D, if they're outside, they get it from the sun, but they can also get it dietarily from hays and also from, again, vitamin supplements. Vitamin E, high-quality legume hay, dehydrated alfalfa, wheat germ, again, vitamin supplements. A, D, and E are usually the ones we will see requirements for A, D, and E in our nutrient requirement tables, and we will supplement those very often in the mineral mixes or the vitamin packs. Vitamin K, K2 is synthesized in the rumen, and again, the other K, K1, comes in the same high-quality forages. And as I already mentioned, B is not required in the diets of animals. I don't know if you can see this picture real well, but these guys are eating red clover, so they should have a real good source of vitamins. And as I mentioned, there's an awful lot of interactions between nutrients, and the ratios really matter. And particularly these are just vitamins and minerals, but we do have interactions. We do have interactions between other nutrients as well, but in particular with the vitamins and minerals. And one of the things that becomes really important is if you feed what I'm going to call non-traditional feedstuffs, for example, distillers grains, which is the byproduct of producing ethanol, that can actually create a copper deficiency because of the sulfur content of the feed. So anytime you feed something, I'm going to say more non-traditional that we aren't, that we don't have as much experience with, we always have to be concerned about some of these interactions. Sometimes they interact and affect diseases, work together in the body, and sometimes they affect the availability of each other. So there's just a lot of different interactions. And what about fiber? It's not a nutrient per se, but it's certainly an essential dietary component, certainly for ruminants, but even for people. We talked about the importance of, or the effect of roughage or fiber, how it affected the rumen. The fact that the more forage in a diet, the more propionic acid you get, higher milk fat. Actually, I got that wrong. It's acetic acid. But we talk about how how you get different bugs, and essentially fiber is very important for ruminants to keep a healthy rumen. And also when we look at rations, fiber has a lot to do with the digestibility of them. So if you get a feed analyzed, and if you look at dairy goat ration balancing, you'll see the terms ADF and NDF, and they stand for what I'm showing up here. And they include different components of the cell wall. And basically, as those fibers increase, forage quality goes down, so they're getting less. It's less digestible, and as an NDF goes up, they consume less. And there is actually a formula where you can calculate TDN from ADF. But while they need fiber, obviously, the higher the fiber is, the lower the digestibility is, and the lower the intake can be. So we do look at these numbers. So they need it, but we don't usually balance it. Yet we know they need a certain amount of forage in their diet. And we know that when we change from a predominantly forage or forage diet, if we want to change to a more concentrated diet, we know that we have to do that very slowly. And hopefully we understand now that when we do that, the bugs in the rumen change, and lactic acid is produced, and things like that. We know that we have to be very careful. So fiber, while not directly a nutrient, is very important when we're feeding ruminants. The rest of the session, I wanted to talk about what the animals require. I've noticed a few questions about, well, what's the protein requirements for this animal and this animal? We don't actually have to guess. We can look it up in tables. We have all that. And what I'm going to do with the rest of tonight is I'm going to try to show you how the nutrient requirements vary based on these criteria, and I've made graphs, and I'm hoping that the graphs are a good way to illustrate it. And then after each graph, kind of say, well, what's the main points we should get from these graphs? And I've got a mixture of sheep and goats and dairy animals in the graph. So hopefully it'll represent enough, and you'll get the general idea. Because again, tonight's not about the mechanics of how we're going to feed. We're not there yet. We want the background information and the understanding. And then next week, talk about what the feeds give us. And then the next two, how we put that information into balancing rations and feeding our livestock. This first table is about how do the nutrient requirements how are they affected by species? There's many of us that have both species, sheep and goats, and on the same farm, and maybe even in the same pen at times. And then also looking at the differences in, well, is it a dairy animal or is it a non-dairy animal? And how does that affect nutrient requirements? And so here we're looking at a 132-pound female. She produces twins. Regardless of what species she is, she's 132 pounds. Regardless of what purpose she is, she's 132 pounds. And how do the nutrient requirements vary? And we go from maintenance, which is basically the same as a pet sheep, but a dry animal that's not doing anything, to the early part of gestation. Nutrient requirements, as you can see, go up a little. Late gestation, they go up, and lactation, they go up. What I mean by parlor milk would be an actually dairy animal, that we're removing the lambs of the kids and we're milking them. So we're milking them for high production. So as you can see, their production, you look at the last two bars, are significantly higher than any other bars on these dairy animals. They're not different. Their nutrient requirements for a dairy animal aren't different for maintenance, early gestation, and late gestation per se. It's when they're lactating that the nutritional requirements are much higher. So what those graphs should tell us, first thing they should tell us is sheep have a lower maintenance requirement than goats. So if I'm simply have sheep and goats in dry lot and I'm feeding them hay, I don't need to feed as much to the sheep. Same body weight. Dairy goats have a higher maintenance requirement than meat and fiber goats. And then, as I said, females with a higher genetic potential for milk production, and that's going to be our parlor milked, and it could be hand milk. I just use the word parlor because that's what they tend to put in the nutrient requirements. They have a significantly higher nutritional requirement. And that's not rocket science. You know that a meat goat needs less feed than a dairy goat. It produces less milk. Dairy goat needs significantly more, and the same parallels are true with sheep. In fact, the animals that would need the least amount of nutrition would be if you were strictly or predominantly raising them for fiber. They would have the lowest nutritional requirements. In fact, you'll mostly find the fine wool, which is the wool that brings the most money in the marketplace, and Angora or mohair. They're raised in areas where nutrition is not very good. Not very good. So the nutritional requirements are the highest for milk and the least for fiber. But very often you're combining those production systems, certainly with fiber and meat. What about the size? How does the size of the animal, and size to some degree is going to get it breed. Do you have a 110-pound, trying to think of a sheep that would be 110 pounds, St. Croix? Or do you have a 154-pound Katahdin or 198-pound Shropshire? How do their nutrient requirements vary? And as you look through the graphs, you can see that as she gets bigger, she has to eat more. She has to eat more. But under energy, I put the percentage. Now, when we use percentages, I want you to keep in mind, animals never require percent anything. Percentages are given because assumptions are made on what they're eating. And so we can use percentages. And you have to have a way to buy feed and to analyze feed. But the requirements are in pounds. They're in pounds. All the graphs are in pounds. But that big U, while she has to eat more, she doesn't need as digestible a diet, and she doesn't need as high protein. So if I switch over to goats, this would be a non-dairy doe. That's the terminology they use in the nutrient requirements, so it could really be an Angora doe or a meat goat doe, but she's in late gestation. She's got twins. So I got a 66-pound doe. Let's just say that's a pygmy, and 110-pound Spanish, 154-pound Boer Alpine or something. Again, the same, very similar kind of thing. The bigger the goat, the more that has to eat, and it doesn't need as high the bigger goats don't need as much percentage of energy. Ironically, yeah, that's pretty much true all the way through. So again, if I summarize for these different size sheep and goats, bigger animals have lower maintenance requirements than smaller animals. And by that, it doesn't mean they eat less, it means they eat less percentage of their body weight. A 100-pound sheep has to eat a greater percentage of its body weight to maintain itself than a 200-pound Suffolk or 200-pound animal. Same analogy with goats. But they need to eat more. More total pounds of energy, more total pounds of protein. But the smaller animals need to consume a more nutrient-dense diet. So they're eating less food, but it has to be more dense. In other words, it has to be more digestible. It has to be higher in protein, it has to be higher in energy on the smaller animals. All other things being equal. What about age? Many of us breed our ewe lambs and our doelings. And this graph looks at the nutrient requirements of different size. It's kind of harder to look at this because obviously a ewe lamb and a doeling tend to weigh less than the mature female, but this is kind of the best way I could to go about it, because a ewe lamb weighs less, so she does eat less. She does eat less. But when you look at a percentage of TDN, it needs to be significantly higher, so she needs to eat a more digestible, higher quality diet. Protein requirements don't really change that much, but she needs to eat a higher energy diet. If we look at calcium and phosphorus, because anytime we're talking about pregnant and lactating females, we really want to look at those. They're an important component of the fetuses. They're an important component of milk, so we do look at it. And again, it's you can't really tell from this graph, but it's pretty much the same thing. They need a more dense diet. So our mature females, this is a picture of a ewe lamb, they need to eat more because they're bigger. So more pounds, more grams. But the young females, they're smaller, they can eat less, but it needs to be higher quality. Higher percentage of energy, higher percentage of calcium and phosphorus. No real change in the protein requirements. So what this means is ideally, one of the poll questions asked you if you separated your production groups. If you ask me, this is one of the most important production groups to separate. If you breed a ewe lamb or doeling so that they're going to be a mom by the time they're 12 months of age, 12 to 14 months, they should be fed and housed separately because they need a more nutrient-dense diet, and that might be a much better quality hay or it might be some grain supplementation, but they're going to need a better quality diet than their mature females. Okay, stage of production. In this example, it's a 76-pound ewe. Mature ewe, maybe something like a Dorset or a Polypay. Again, I'm going to assume she's carrying twins. We can just watch as she goes through a production from maintenance to the early part of gestation to late gestation into lactation. It's just a linear increase. A linear increase in terms of what she needs. The big difference is, if you notice under energy, as you go from the blue bar, which is early gestation, to the red bar, which is late, she's not eating that much more, but it needs to be more nutrient dense. You know, most of us, and it's a general recommendation that you feed some grain during that last month of pregnancy. On pasture, it could simply mean better quality pasture that last month, but it needs to be a better quality and more nutrient-dense feed. And that's during that, as we go from early to late gestation when those fetuses are growing. The big jump in lactation, the big jump in protein is during lactation. Not that much in pregnancy. If we look at the mineral requirements, they basically go through that same linear increase, except calcium actually goes down in early lactation. I've never quite understood that particular number, but that's what's in the book. Yes, you can feed wheat to lambs. It's higher in energy actually than corn. You just don't want to feed more than 50% in the ration because it can pack in the rumen. Sorry, David, I took that question. What we get out of those last graphs are that energy requirements late gestation are significantly higher than maintenance, about 50%. And again, we always got to remember there's a limit on how much food they can stuff into their bodies. It's probably more of a space issue than a time issue, but maybe both. And the poorer the quality of the feed is, the more they have to eat. So basically, as productivity increases, that feed we put into them needs to be more nutrient dense. It needs to be more digestible. That can mean better quality forage, or it can mean more nutrient dense feeds, such as our concentrates. In terms of protein, again, we don't see a significant increase until the female begins to lactate. The one thing I will add about that is there has been work that shows that if you increase the protein above the NRC requirements during late pregnancy, that will help that ewe combat parasites. Once she lambs and begins to lactate, same with the doe, she loses some of that natural immunity that she built up with age, and increasing the protein can help reduce fecal egg counts and thus pasture contamination for the lambs and kids that are being born. These graphs would show that calcium requirements are the highest during late gestation and phosphorus are the highest during lactation. One of the issues we deal with, and it varies based on whether it's a dairy or a meat or fiber animal, is milk fever is when they're not getting enough, typically not getting enough calcium during late pregnancy. It's low blood calcium. It can also be caused by too much calcium. And I think that's particularly true with the dairy females, which are more likely to get milk fever after lambing or kidding. But this can be a significant nutritional problem. Looks very similar to pregnancy toxemia, and we will look at that. Okay, stage of production. Let's switch over to a meat doe, 132 pounds with twins. Basically, again, we follow a linear pattern, except when we get to energy and protein. This, you notice I got question marks after these because, boy, they don't make sense to me, but this is what's in the book. It actually reduces energy and protein requirements after they lactate. I probably don't believe those. Looking at calcium and phosphorus for this this doe, again, you're looking at a fairly linear, other than the early and late gestation are pretty similar. One of the problems we have with data, research data with our species, particularly goats, but even to some degree sheep, we often don't have enough data. And so sometimes we don't get as good information as we'd like to have. But again, much like the ewe, energy requirements are going to significantly increase in late gestation when the fetuses are growing. Calcium and phosphorus are going to increase. And again, that lactating female, the one with the dairy goat, they go up significantly in lactation. Otherwise, the lactating female is very similar. What about the nutrient requirements based on level of production? I'm going to assume 154-pound ewe in late gestation, whether she has a single, twin, or triplets. We don't actually have different nutrient requirements for 4 lambs. It takes a pretty extraordinary female to raise 4 lambs, but I suppose some of them do it. So looking at the nutrient requirements, I think you notice that the bigger increase in terms of quantity of food is for that female with triplets. I essentially think a ewe or doe with triplets should get all the food she can eat under kind of a controlled circumstance. I mean, not free choice grain, but a significant amount of grain and all the high quality forage she could eat. And that this graph would kind of show that. In terms of the density of the diet, the big change is when you go from a single to multiple births, both in energy and protein. We need a more nutrient-dense diet. Calcium and phosphorus, basically linear. More lambs, more milk, more requirements for these nutrients. So what we need to get out of this is that ewes carrying twins and triplets need to eat more, all the way through. Dry matter, energy, protein, calcium, and phosphorus. But again, there's a limit. Look at this ewe here. I recall she had 3 lambs in there. There's a limit on how much feed we can stuff in there. So as her nutrient requirements increase, we need to put better quality food in there. Again, better quality forage or more concentrate. And the big difference, like a single, I would practically say you could get away without feeding any grain or not having even the highest quality hay in the world. But once we get to 2 and 3, I think we really need to make sure we're meeting those nutritional requirements, particularly in late pregnancy. When you get to lactation, a lot of it has to do with the level of performance that you desire. You know, more feed, more milk, more growth, and it becomes some economical decisions. Ketosis is pregnancy toxemia. That's low blood glucose, basically an insufficient amount of energy during late pregnancy. We'll talk about that in our final session, but it usually comes down to they're not getting enough energy in their late pregnancy diet. Fat ewes can be particularly prone to it because they'll break down the fat off their back into ketone bodies, which are toxic. Thin ewes carrying multiple births, it's commonly called twin lamb disease as well. Old or timid females that don't get their share of food, all of those can be candidates for pregnancy toxemia. And you could never have had it and think that you're not doing anything different and then 1 year have it. And I think you got to realize that in particular forage quality changes significantly from year to year, and so things can change. What about the level of milk production? And this is looking at a ewe in the early part of lactation, say the first 6 to 8 weeks. Single lambs, twins, 3 lambs, and then that parlor milked or that dairy ewe. Again, the single lamb, the ewe with the single lamb producing milk for the single lamb definitely separates her out in terms of the quantity of feed that she needs, the density of feed that she needs, both in energy and protein. The ewe with twin lambs doesn't need to eat significantly more, but she needs a much higher amount of feed, higher quality feed, more digestible, higher percent TDN. And the big jump comes in our parlor milked or our dairy ewe. 80% TDN is an extremely high energy ration. 19% protein is an extremely high protein ration. Keep in mind that corn is 88%, barley is 84%, so you're looking at significant amounts of grain to meet her nutritional requirements. Does that mean you can't raise dairy females out on mostly forage? Sure you can, but you're probably not going to meet their nutrient requirements for that level of milk production or for maximum milk production. And that's a decision that economically you have to make for yourself. More is not always more profitable. But where you don't skimp, again, I'm going to say is late pregnancy. This happens to be lactation. But you never skimp in late pregnancy because that's not a matter of choosing a level of productivity. Lactation diet is choosing a level of productivity, but late gestation, depending on how many babies are in there, you need to meet those needs or you're inviting problems. And one of the challenges that producers have is knowing how many fetuses a female is carrying. You kind of get to know your flock, and you kind of get to even know individual animals if your flock is small enough. But if you had a really large flock and your reproductive rate was 1, 2s, and 3s all over the place, you could scan them and separate them into production groups, and that would be a profitable or an economic for some situations. Keep in mind when we give percentages, those percentages again are based on consuming a certain type of diet, usually a traditional hay grain diet. And there are also percentages for the entire diet, not just the grain portion of the diet. And they're guidelines. That's all they are is guidelines, because again, we don't balance a ration on percentages. We balance it on pounds per day or kilograms per day. They have quantities they require, not percentages. Okay, now we're switching over to the dairy doe, 132-pound dairy doe in early lactation. Again, it's just basically a linear increase with the triplets and the parlor milk female producing, needing significantly more energy. You notice that I do not have protein requirements on there. The nutrient requirements in the NRC book are really wacky. They're like 5% for each of these goats, and so I can't possibly think they're right. And I think it gets back to some of the lack of data that's available for those nutritionists to extrapolate and create the right numbers. But I'm sorry I didn't provide that number, but they just don't make sense to me to have diets that low in protein, whereas if we go back to the sheep, we've got our dairy ewe getting a 19% ration, and our moms raising twins and triplets getting a 15% ration, and those make sense. But when I got to the dairy does, unless I totally screwed up the math and I did it over and over again, the numbers just weren't right. And I hate to say that because that's not a good answer for you. So as we look at the dairy or the milking female, the more milk she produces, the more nutrients she needs. Energy, protein, and minerals. In some cases, you just feed them more, right? You know, give them another pound of grain. You know, it's customary in the sheep business where we kind of give them free choice forage and then a pound for every lamb they're nursing. And that can kind of work. But in some cases, it doesn't work. They can't really eat anymore. So again, I get back to the idea of a more nutrient-dense diet, and that requires more nutritious feeds. And of course, anytime we're pushing towards a more nutritious diet, that usually means concentrates, and we've got to be slow about it and gradual about it. You know, one of the biggest mistakes people make is, you know, they'll have a ewe that has triplets and they'll just start pouring the grain to her. You know, she doesn't really need any grain that first day, but everything's got to be gradual, gradual. And again, the requirements for our dairy females are significantly higher. What about the babies, the growing babies? They're pretty much affected by the same factors as the ewes and does. And there are some choices you make in terms of the level of performance that you desire. If you want them to grow more, grow faster, you know, there are some decisions that you have to make on your own operation. Purpose of this today is really just to understand how the requirements are affected by these different factors. The first thing is, and I think this is the only example I have with lambs, but I don't really find lambs and goats, the concepts that significantly different. The numbers may be different, but the concepts of how this affects their nutrient requirements is not that significantly different. Nutrient requirements of lambs are based on age. Many times we feed very young lambs. I know in my operation, once the lambs are born, I'll set up a creep feed, and by the time they're 4 and 5 months old, they're ready for market. So I grow them very fast when they're young. Other situations, lambs may go out to pasture or go out to range, and they may come back into a feedlot. If they're not marketed off the forage, they could come back into a feedlot. And so often we'll be feeding an older lamb. And then we have different genetic types, early maturing lambs versus late maturing. I might think of most of our traditional British breeds as the early maturing, and most of our, what I would call our Western whiteface, Rambouillet, Columbia, that sort of thing is our late maturing. So this graph is kind of looking at both. So in the first situation, we're comparing when we look at the green and the blue bars, that's comparing different age lambs of the early maturing group. And essentially, you can see that older lamb has a higher nutritional requirement in terms of how much feed he has to eat as a percentage of his body weight, and he needs a much more nutrient-dense diet. On the other hand, he doesn't need as much protein because, as we mentioned, as they get older, protein requirements decrease. If we switch over to the late maturing lambs, basically both of them need higher nutrition than the younger lambs or than the early maturing lambs, but the same ideas hold true. The older lamb needs higher nutrition. So basically, if you assume the same rate of gain on lambs, and in this case I chose 2/3 of a pound, basically understand that a young lamb converts feed more efficiently. If you're going to feed, I mean, I've always felt if you're going to feed concentrates to lambs or goats, you should do it when they're young and most efficient. They do need more protein because they're younger, higher percentage of protein, but they convert feed much more efficiently. So our older lambs need to eat more pounds, and that diet needs to be more digestible in order to achieve the same rate of gain. And if you looked at feed efficiency, it's definitely, again, it's going to favor the young lambs. When we put lambs back into feedlots that come off of pasture, come off of the range, we're looking at, depending on the composition of the diet, we're looking at double the feed efficiency. I mean, twice as much feed to put on a pound of gain. Basically, our late maturing lambs need to eat more, very similar to the older lambs, and they have lower protein requirements. Now most of our examples are going to look at goats, look at meat goats, or goats in general. And in this example, I'm assuming we have goats that are gaining, we want them to gain 100 grams a day, which is about 0.22 pounds. Remember, these are little guys. That's not a horrible gain. So as we increase weight, obviously, they need more of everything. They need to eat more, but the chart may show it a little bit better. They need a more concentrated diet the younger or the smaller they are. And they need more protein in the diet the smaller they are. All other things equal. So the bigger kids need to eat more, but the smaller kids need to eat a more nutrient-dense diet. And that should be a common theme when you think about it. That smaller sheep, that smaller doe, doesn't eat as much, but needs to eat a more nutrient-dense diet. The bigger animals, from a standpoint of maintaining their body, are more efficient. They eat more, but as a percentage of their body weight, they eat less. So a higher percentage of what they eat is going into production. So the same thing holds for kids and lambs. Now if we look at different genetic types, and in this case in goats we're comparing a dairy goat, buck, a Boer buck, and Boer would be to me any improved breed, like it would include Kiko and things like that, and indigenous would be just kind of a goat. And I think we have some similarities in the sheep business, not so much the dairy meat comparison, but some of our better growing or genetically superior market lambs, the Suffolk, Hamp, Dorset type market lambs, crossbred market lambs. We might think of them more as the Boer, and the indigenous we might think of some of our rarer or rarer type breeds. So as I look at the difference, what we see is kind of some things that go up and down. Keep in mind the Boer goat is the one in the middle, so he needs to eat more. He needs to eat more. But he needs more protein, but he doesn't need a higher percentage of energy. That goes with the dairy. And if you remember back to the dairy doe, she was a higher maintenance animal than a meat or fiber doe. So again, some of it parallels. In the case of goats, the dairy genetic type has higher maintenance requirements. So again, we assume the same rate again, in this case 0.44 pounds, which is pretty good for goats. The dairies, they don't need to eat as much per se, but they need a more nutrient-dense diet, so they're not as efficient. And Boer goats need to eat more, but their diet doesn't need to be as energy-dense. They have a higher protein requirement. And the local breeds or indigenous breeds have lower requirements for protein. This happens a lot when we export a breed like the Boer, or even say a breed like the Suffolk, into countries, developing countries, that don't have the nutrition. These animals require that better nutrition, and they go into some of these countries and really don't do well because the feed isn't ample for them. So when you bring in some of these, what I'm going to say, genetically superior animals for growth, our improved sheep and goat breeds, they're not going to do well unless you ratchet up the nutrition for them. The local breeds, on the other hand, will do just fine. And dairy goats, of course, in order to get very high production out of them, also need higher nutrition. What about the sex of the animal? And again, I think this is analogous to lambs. If we were feeding wethers versus rams versus ewe lambs, essentially the intact male needs more food. He needs more food. He needs to. He needs a. This doesn't show us the percentages yet, but he basically needs to need more food. When we look at it, they need more dry matter and energy. No difference in protein. No difference in protein in terms of the amount, but the doe is going to need a little bit higher protein because she's eating less. So because they have a little bit different nutritional requirements, it makes sense to separate them. But I think more important, and I realize if we have bucks and does, we should separate them. But let's say that would also make sense from a standpoint of we would feed them differently. Not only do they have some different nutritional requirements, but we don't want females, maximum gain on females, usually. Let's look at growth rate. This is just taking, again, 44-pound Boer bucks, taking them from not gaining anything, just maintaining them up to 0.55 pounds per day, which to me is a pretty good rate of gain, and a few of our 4-H kids will achieve that with their animals. Pretty much, although you've gotten in terms of the amount of feed they're eating, you got a little bit of staircase in the graphs. For the most part, it's linear when we look at the energy and crude protein requirements to get the different gain. And it doesn't take a rocket science to figure out that if you want animals to gain more, you have to feed them more. And both a quantity of feed and a quality of feed, not just one or the other. Higher percentage, more pounds of food and a higher percentage of energy and a higher percentage of crude protein if you want them to grow better. The question is, what's the most economical rate of gain on your place? I mean, if you look at the table there, when we go from maintenance to gaining 0.55 pounds per day, I mean, you almost see almost a tripling of the protein percentage and almost a doubling of the energy percentage. So those are significant differences. And you have to decide whether that's economical. It's almost always, to me, going to be more economical to try to provide a higher quality forage. Doing a better job with your pastures in terms of the pasture mix, in terms of rotating them so that they're eating when it's more in a vegetative state. That's probably almost always going to be economical. The question of supplementation or even putting them into a feedlot, those are questions that you're going to have to answer on an individual basis. We just got funded in Maryland to do a study where we're going to look at taking goats and putting them in a pen and giving them free choice grass hay and hand feeding them grain once a day. And we're going to compare those to goats that are going to be grazing strictly pasture, and we're going to try to take some samples of the pasture so we get a handle on the nutrition that they're consuming. And we're going to look at their performance, we're going to look at their carcasses, and then we're going to look at the economics. And that's something that we're going to do and hopefully provide some valuable information to producers, but ultimately it would be questions that certainly from the economic standpoint that individual producers would have to answer. But in this case, we expect a higher rate of gain because they're going to have a more nutrient dense ration, primarily because of the grain. Hay and pasture aren't going to be that different. In fact, pasture is usually better quality than the grass hay that we'll be feeding. If we were doing the same with lambs, we could make the same comparison. I think again, a lot of the things are the same whether we're doing lambs or goats. And I actually did pretty good keeping this within an hour. I actually thought when I counted all the slides that it was going to be a hard time to keep it within an hour. Next week, Jeff Semler, the county agricultural agent in Washington County, my home county here right near the research station, he is going to do the session, and he's going to talk about the feedstuffs. And then, like I said, the next two we're actually going to talk about, well, now that we kind of know this kind of stuff, how do we actually apply that in feeding? And in the first session on what I call nutritional management, I kind of want to look at it before we do the math. And then Willie Lance, who's the Garrett County Extension agent, he's going to do one on ration balancing. We're going to look at actually balancing rations with math. You can do that by hand. There's lots of tools to help you do it. But I also realize that most of you aren't going to balance a ration. So what are some of the general ideas for feeding, kind of the general recommendations, and some things that you can do to see if you're feeding right, and then look at some full-blown ration balancing, which to me isn't that hard with these online tools. There's online tools for sheep. There's online tools for goats. I have a whole bunch of spreadsheets myself, so there are tools out there to help you do that. The only thing we can't help you do is you got to weigh stuff. I asked you a question in the survey about, do you weigh your females? I don't mean weigh them all the time, but if you don't know what your females generally weigh, and this would be like a pre-breeding weight, not when they're full of babies, it's hard to balance a ration. Because even if you don't balance a ration every year or every season, every once in a while you ought to check it to see if you're meeting the nutritional requirements. And that's kind of what we'd like to focus on a little bit, how to truly